Yeah, students, sir, you can copy and paste, no, sir. Why sir you're typing again?
Where?
Previous message. Yesterday you said, no, sir, that you can copy and paste. So please join.
Please compulsory have to put on.
Signature step. 2 times for
We'll talk continuously, Vishal, in your house also.
There's no one to talk with, sir.
No one wants to talk to you in
No,
your
sir, no one
house.
to talk with. Teacher also went.
Where? Because of you, she left the house.
No.
Huh?
College, sir.
College. Okay.
How many participants? No one. No one is
You'll join slowly.
Sir, you copy many paste here.
How to check whether they have seen or not?
Click that, sir. Message info. First
Message info. Okay. Who is this guy? 6374120. They also saw now 29 remaining.
29 remaining. They still have to see. Delivered means like the message is delivered, they did not see.
Okay. In this 11th IIT?
Same way. No one saw, sir. What is it?
Okay. Anyway, you came now. You are very important to me.
Chiranjeevi, sir. Commander. Dates. Sir, black, sir, please.
I will change.
Change the whole thing to black, sir.
Dark.
Dark thing, sir.
Okay, anyway, so I think yesterday you people have seen a wave equation. Correct?
Yes, sir.
Once again, I will give a very quick recall. So this is any frame of reference. Let's say this is any x-axis. Let's say this is any y-axis here. One wave is going like this. One wave is going like this. We are targeting one particle which is at a position x meter after t seconds. So vertical displacement of the particle is y. Then tell me what the wave equation. When wave is going right side, y is equal to how much? A into sine of kx minus omega t plus pi. This is called wave equation. Okay. Now, for suppose if I want to find this is nothing but y is nothing but what? Displacement of the, vertical displacement of the particle only.
Yes, sir.
Name alone wave equation, but exact meaning is vertical displacement of the particle at what time? At t seconds. Correct. Now I want velocity of the particle. Velocity of the particle. What I have to do? Velocity of a particle. What I have to do? I have to differentiate on both sides. Na?
With respect to time.
So, yes, velocity of the particle is nothing but what? Change in vertical position by change in time taken.
Yes, sir.
So substitute here. What do you get? D by dt of y value how much? A into sine of kx minus and omega t plus pi.
So this is only like a standard wave equation, sir.
Yes, this is a standard wave equation.
Kx minus omega.
Yes. In different cases, yesterday only we have seen, na?
Yes, sir.
Okay. So a is constant, na? I will take it outside. And what differentiation of sine?
Cos.
Cosine. And kx minus omega t plus pi. And you have to differentiate once again, na? Correct or not?
Yes, sir.
If you differentiate once again,
derivative of kx minus omega t plus.
here x is always constant.
K is also.
K is equal to called here what? Wave number.
Oh.
What a wave number meaning?
The wave number is it?
Number of waves accommodated in 1 meter distance.
Yes, sir.
Is called wave number. This formula you have to remember compulsory. And x constant, k constant. What differentiation of this kx?
Yes.
0.
Oh, 0. Okay.
Differentiation of any constant 0 only, na? Differentiation of this pi also 0.
0.
So only time is variable. Minus omega only will come outside.
Minus omega will come outside.
Yes.
And,
So then yes. Velocity of the particle how much? Minus a omega into cosine kx minus omega t plus pi.
Sir, 5 not. Oh.
Pi will
minus omega will come, sir.
minus omega I wrote here.
Oh, along with that. Okay.
Okay, this is the velocity of the particle at what time? At t seconds. After t seconds, is the velocity of the particle. Now,
So once again, I will copy this.
yeah. Now, I want to see the snapshot of the wave. Snapshot of a wave. Snapshot means screenshot. One wave is going on the surface of the river. How you take the image? It will be like this only, na?
Yes, sir.
Means you are analyzing different particles at different vertical positions. If you take another particle q, it is having different horizontal position x1, it is having different vertical position y1. Says or no?
Yes, sir.
Means for different particles, x changes with y changes. Correct?
Yes, sir.
But in previous case, we discussed only one particle, na?
Yes, sir.
One particle only which changes? Only y changes if time changes. Says or no?
Yes, sir.
That is the difference between one particle and many particles. Did you understand the concept? Now we are talking snapshot. Snapshot means different particles, different medium particles we are talking. So I can write change in vertical position with respect to change in horizontal positions, na? Different particles. What is the meaning of the snapshot or screenshot or photo? Same time, no? The time is constant, na?
Yes, sir.
That is the concept of snapshot. Means for different particle at a horizontal position, they are at a different vertical position. Then y decided by x. X changes, y also changes.
So we can add dx by dy.
No. Only we are talking vertical change in position, na? Particle is oscillating along y axis only. So change in vertical position only you should write in numerator. Are you understanding? So dy by dx how much? D by dx of y value how much here? A into cosine of how much? Sorry, y value this one. A sine. Sine of kx minus omega t plus pi. So what do you get? Dy by dx equal to A I will write outside. What differentiation of sine? Cosine kx minus omega t plus pi. Again, this total term in the bracket you have to differentiate. As I told you, time is constant, omega is constant. If you differentiate, it will be 0. Initial phase is also constant, it will be also 0.
Yes,
correct? But which is variable? X alone variable. If you differentiate kx, only k will come outside. Correct?
Yes, sir.
So I am writing k. So what is dy by dx equal to? A into k into cosine of
Cos.
kx minus omega t plus phi. I will assume this is equation number 1. I will assume this is equation number 2. Is it clear?
Oh, that velocity is what?
Velocity of the particle is 1 and this dy by dx is 2. I will divide these two equations right now. I will divide this two equations. So what will happen? 1 divided by 2 means what will happen? Left side's Vp by
dy by dx.
dy by dx equal to how much? Right side minus a omega into cosine kx minus omega t plus phi and whole divided by how much? A into k into cosine of kx minus and omega t plus phi. Cosine, a cancels out. So what we can write? Velocity of the medium particle equal to minus omega by k into dy by dx. As I told you yesterday, angular frequency by k is nothing but velocity of wave only, no?
Yes, sir.
Velocity of wave. This also you have to remember. Okay, so this is the most important relation, friends. Is the relation between velocity of the medium particle and velocity of the wave and into dy by dx. So in the waves chapter, it have more predominance, most significance is there. Very useful equation. Now I will explain its application. What is the advantage of this application? Now I will explain. This is what relation between what and what? Velocity of particle and velocity of particle and velocity of wave. Okay, so usually you will have lot of doubts. Sir, how will you apply in different situations? Sir, definitely you are very curious to know the applications. Before that, I will ask one question. You people have to answer it. Are you ready?
Yes, sir. Yes, sir.
This is one snapshot of a wave. What the meaning of the snapshot? Tell me.
Time is constant.
Snapshot means I will shake one rope with one camera. I will take a picture. So one wave I can take the screenshot, no?
Yes,
Snapshot. So means that is nothing but graph between y and x only, na?
Yes, sir.
All particles, particles of the rope will be like this only, no?
Yes, sir.
Say yes or no, everyone. Not only rope, in the ocean, in the surface of lake also, the tides will be in this shape only, na? This is called one full wave. Correct or not? Now, but this wave is going right side, students. This wave is going right side. Now, my question is very simple and very straight. This one particle P is there. This particle P at this moment, it is going upside or downside is my question. That's all.
Upside.
Upside. How?
We are doing like this. Oh. That particle alone, sir.
Are you understanding my question? Are you understanding my question? My question is find the direction of the particle P.
So we can find the velocity and we can find its direction. P is equal
Wave is going right side.
minus V.
Now you will.
Sir, wave is going right side means that particle will move opposite side, sir. Because Vp is equal to minus V W.
No, not like that. Okay. At point P, I will draw one tangential line.
Yes,
its slope is positive or negative?
positive.
Positive. So I will give some real number dy by dx compulsory plus. I will give +1. No issue, no? No issue, no?
No, sir.
Then velocity of wave, I will assume roughly it is some 1500 meters per second. Plus I have to give. Why plus velocity of the wave?
Right side.
It is going positive x, na? So plus I have to keep. Now both of you substitute here. What do you get? Velocity of the particle equal to minus velocity of wave is 1500. Dou by dou x slope is how much? +1. So velocity of the particle how much? Minus 1500. Why you got negative sign? The reason is particle P is going downside. Everybody understood, huh?
But how, sir? How we can tell it's going downside?
Negative sign it came, na? What is the meaning of the negative sign?
Opposite direction, sir. But we don't know what is the initial direction of the particle, sir.
Initial direction of the particle going downside only. It is doing oscillations along y-axis only, na? Vishal.
Yes, sir.
Then we got minus 1500 only, na?
Negative way.
Then negative y-axis. Downward. That's all. Now it is turn. It is your turn. Tell me what is the direction of the velocity of particle Q? Everyone.
So the slope will differ, or
Sir, down, sir.
Not down, not up. It is rest. Understood? It is at extreme position, Ajiva. Any particle which is doing simple harmonic motion at extreme position, what is the velocity, Jiva?
0, sir.
0, sir.
That's it, 0 only. It is not going up, it is not going down. Clear?
yes, sir.
Sir,
Why
but
you-
velocity of the particle we got as minus 1500, no, sir.
First, tell me the answer. Why are you online?
Sir,
Srinidhi and Jiva Kamal. Will remove the online.
Sir, I have my final exams going on, sir.
Final exams means when Srinidhi?
Sir, no, my final exams are, the session ending exams are going on, sir. School.
Oh, you, Mr. Jiva, is thinking what I should. Jiva, tell.
sir, I'm feeling tired, sir, so that I didn't come today.
Okay. Okay. Now you are asking something, Jiva. Tell me. Continue.
No, sir, you said that particle P is at rest, no, sir. Now 0, you said, no, sir.
Article Q, I said rest. Q,
Okay,
Q
sir.
is at
Okay,
rest.
okay, sir. Okay.
It is at extreme position, na Jiva. It is not going upside, not going downside, no?
Okay, sir. I
Anyway-
thought you was asking for particle P and I said it's going downwards.
At that moment, when you have taken the image, P is definitely going downside. No, if particle Q about to go in which direction means it is about to go definitely downward direction only, na? Are you understanding?
Yes, sir.
At that instant, it is rest. But about to go downward only, na?
Yes, sir.
Are you understanding the difference? About
Yes,
to
sir,
go
yes, sir.
downward.
So no particle will be upward, sir. In this one crest, no particle will be going towards upward, no, sir.
It is going upward only, na? This particle. Take this another particle R. It is going upside only, no?
No, negative.
Understood? R particle is going upside only, na, my dear students?
Then up to
Yes, sir.
half of the crest it will move downwards, and next half of the crest it will come upwards, sir.
Not like that. You cannot say. You cannot use that logic. Are you understanding? Now, few more questions I will give. Without opening your mouth, you have to give answers only. Clear? Clear? You
Sir,
can.
without opening the mouth, how can we answer, sir?
We'll write and give you the paper, sir.
You have to chart and offline students just raise your fingers. Okay, are you ready? Are you ready? See, This wave is going left side this time. This wave is going left side.
Okay, sir.
And what is the status of this particle P? What is status of particle Q? Going upside or downside? Or tell me quickly. That's all.
Okay, sir. Particle Q.
I said the condition. Huh?
Hmm.
What condition? Srinidhi, if Srinidhi is present, you do.
Hey, don't open your mouth.
Sir,
Tell
chat
here.
is disabled, sir, so that I will say the answer.
Tell,
Or-
no issue.
Sir, particle P goes upward, sir.
Particle P goes upward. Very good. Perfect. Particle Q then goes downward. Correct only.
Yes,
Perfect.
sir.
Hmm.
Then particle R, tell me.
Goes down, sir.
Goes down. I too don't know. I will check it.
So,
So
Sir,
at,
because negative slope.
at particle R, slope is what? dy by dx is
negative.
negative. I will give some number, real number. And the velocity of the wave is
Minus.
some -2.
Hmm.
Then what is the velocity of the particle? Minus Vw into how much? dy by dx. Substitute -2 into -1. So how much it is?
-2.
-2. Very good. Perfect. Then find the direction of this particle S.
Rest, sir.
Very good. It is no
Rest,
upside,
sir.
not downside. Okay. Very good. Okay, so now very immediately we will move to next concept, transverse waves. What that waves? Transverse waves. In the yesterday session only slightly I have explained
Yes, sir.
what is the meaning of the transverse waves.
Wave motion is perpendicular to particle.
The wave motion and particle motion both are perpendicular main. That waves are called what here? Respond.
Transverse wave.
Transverse
You
waves.
don't have to open the mouth, then how can you respond?
During the question only I said right.
Okay. This
Because
by that for whole class.
see Vishal, I asked you a question.
Hmm.
Then you will ask me
Another question.
another question. So correct or not? That's what you have to think. That's all.
Okay.
That's what I said. Now you can start
Opening mouth.
opening mouth and opening everything. Okay. So transverse waves. What are transverse waves? The waves in which
The waves in which wave motion is
particle
perpendicular to
motion
particle.
and wave motion is perpendicular is called what here? Transverse waves. Can you give some examples?
Electromagnetic waves. Like
No,
waves.
no, wrong. Electromagnetic waves are
Transverse in nature.
transverse in nature, but not transverse wave.
What's the difference between transverse in nature and transverse waves? Sir?
Very good. Acids are different, acidic nature is different.
Yes, sir.
Are you understanding?
Okay, sir. So like
Hmm.
waves.
Real psycho is different, psychic nature is different. Sometimes psychic nature means sometimes you'll behave like a psycho.
But psycho always.
Always says like.
Psycho means 24 hours you'll stay psycho. Understood?
Understood, sir.
So
transverse waves.
electromagnetic waves are which nature?
Transverse in nature. But
Transverse in nature. They are not transverse waves.
So they are longitudinal waves, sir.
Huh? They are electromagnetic waves.
Oh,
No, he's asking if they are not transverse, then what are they?
sir, yes, sir. If they are not transferred, are they longitudinal waves?
Very valid question and very good question. These transverse waves, a longitudinal wave, these two waves must and should propagate in medium. Correct?
But electromagnetic waves.
But electromagnetic waves
do not require
any medium. How did I define transverse wave?
particle motion and wave motion are perpendicular.
Then electromagnetic wave particle is not required. Na? In electromagnetic wave, electric field is there, magnetic field is there. Let me tell Ray Vishal. That's understood. Electromagnetic wave means propagation of the electromagnetic wave and electric field oscillations, magnetic field oscillation, three are perpendicular, not particle. That's what they are, perpendicular in nature,
Transverse.
but they are not transverse wave.
Okay, sir.
You should not tell it is transverse wave.
Okay.
Understood?
Yes, sir.
You said transverse wave means electromagnetic wave, transverse wave means you don't have knowledge of the electromagnetic wave. They do not require medium. No?
Oh, okay, sir.
I can say very confidently, for example, curtain is there. Because of wind, transverse waves will be generated on the surface of the curtain.
Hmm.
Generated or not? Tell me honestly. On the surface of the water also, if you touch continuously, on the surface of the water also, or any liquid also, transverse waves generated.
Yes, sir.
Medium is compulsory.
Hmm.
But you should not call electromagnetic wave. No, medium not
They don't have
required.
any
No.
medium. Okay, sir.
Understood?
Not
Transverse
required.
meaning what? Perpendicular. Okay.
So any other examples?
Transverse wave, while you are drying cloths, what will do? Will jerk the cloths, na?
Yes, sir.
So one transverse wave is
Also,
generated.
like sound wave, light wave, anything. No, light is not transverse. Like I'm asking like that. Any example is there?
Transverse waves generated in the rope. If you take a guitar, what will happen? It is tied between two rigid pegs, rigid walls. What will happen?
When we,
The waves will be like this only, no?
yes, sir.
Wave is going, for example, right side means medium particles are vibrating in which direction? Perpendicular direction.
Upward. No, up, some is upward, some is downward.
Correct or not? Next, on the, if you tap any metal rod, not wire this time. If you tap any metal rod on the surface also, transverse waves will be generated.
Yes, sir.
Only on the surface. Only where?
On the surface.
Only on the surface only I am telling. Understood?
Yes, sir.
And if you take any tsunami means
Earthquake in the sea.
largest wave produced in the ocean. In the normal state of ocean, very small waves are there. Correct or not? But during tsunami, what will happen? Very largest wave is found. That's what on the surface, transverse wave will be generated for a very long wavelength. Not during tsunami, in the ordinary state also, on the surface of the water always, what kind of waves is generated? Transverse waves. Correct?
Yes, sir.
One paper you kept just under the fan. On the surface, you can see the transverse waves. Correct or not? Definitely the surface of the paper is not flat, na? Correct or not?
Yes, sir.
One curtain is there. You dried, not required, right? If air conditioner, see here. I'm jerking. I think online students you also can see. Are you seeing a curtain?
Yes, sir.
See, what waves there?
Transverse waves.
Transverse only, na?
Yes, sir.
Yes, sir.
Your wave is going right side.
Yeah.
What's the-
Background. Which one?
They can see, I think. They only told. You can see no right? Background, curtain. Curtain you are seeing, huh? Srinidhi?
Yes, sir.
Visible.
This wire is there, see. This charging wire is there. Are you seeing? What waves are there? Transverse wave only, na?
So most of the waves are transverse waves, sir.
See, I jerked this. What wave I produced?
Transverse.
If I shake my hand, one full oscillation means I produce one wave.
One wave.
Clear?
Yes, sir.
Enough? More
Yes, sir.
examples you want?
Yes, sir. Yes, sir.
Okay, now, students, I have taken one rope. I attached to one rigid wall. When I attach to one rigid wall, and if I half shaked my hand, how I shaked? Half oscillated. Half oscillated means what? Only positive cycled wave has been produced. Correct or not? So I am taking that one little element, one small element I am taking, but in a magnified view. Actually, very little element I have taken. And if you extend these edges, you will get one perfect circle. Na? Says or no? This is what center of the circle. And I will join this edge and I will join this edge. I will join one line of symmetry. How much angle it will form? Theta. Here, how much angle it is formed? Theta.
Both theta will be equal, sir, or theta?
Theta will be equal. Okay. On this string, tell me, you people, how many forces are acting? This right now wave is going with velocity v only, na?
Yes, sir.
Say the mass of that element equal to dm. Let's say linear density of this string, mu is called here linear mass density. Mu is called here linear mass density. Mu is equal to how much? Total mass by total length of the element. Let's say the radius of the element equal to capital R. Understood? Now, if you see the free body diagram of the element, how many forces are acting? Right side element is pulling this side with tension T. So left side element also pulling this element with tension T. You draw on vertical line. This is theta means this is how much? Definitely theta. This is theta means this angle how much? Please respond. 90 minus theta. Then this angle how much? Theta only, na? Again I am repeating theta. This is 90 minus theta, again theta. Then tension has how many components? One is T cosine theta and other one is what? T sin theta. And this is what? T cosine theta. And other one is what? T sin theta. Here T cosine theta is getting cancelled out. So what is the net force act?
So the force will pull this side, sir.
How?
How the tension will act this side, sir? Left side.
This element, Vishal, only very small element I have taken. Na?
Yes, sir.
Nature of the string is pulling only, no?
Yes, sir.
So this right side part of the string will pull the element this side.
Oh,
Nature of the rope is pulling only, it never push. So left part also will pull like this. Tension, tension, T. Clear? Right now the element is exactly in the circular trajectory only, no?
yes, sir.
Circular shape only, no? Means who is keeping this element in the circular motion or circular trajectory? Centripetal force. Who is providing that centripetal force?
T sin theta.
T sin theta plus T sin theta.
Yes.
So shall I write 2T sin of theta is equal to centripetal force? Somebody please tell me centripetal force formula. Very good. Mass of the element into velocity of that element or velocity of the wave, both are same only, na? I am, for example, one eagle came and caught the snake and fly away.
Yes, sir.
Then eagle speed and snake speed both are same only, na? Correct or not? When wave is propagating through the element speed, wave speed same only, na?
Yes, sir.
Are you understanding the logic, students? Online students?
But always it will be same or like?
Always it is same only.
Okay.
Are you understanding or not understanding? Hello?
Yes, sir.
So mass into velocity of the wave, velocity of the transverse wave or velocity of the element divided by radius of that element. I mean radius of this arc shape. Correct? So I can write 2 into theta. So 2 into t into what does sine of theta means? Theta is very, very small angle, na? Correct or not? So sine theta, if it is very small angle, mean according to small approximation rule, theta I can write now 2t into theta. And what the mass of the element equal to? Mu into length of the element into how much? V square by capital R. You know, according to concept of the arc, what length of the arc equal to? DL equal to how much? R into 2 into theta. Right or not? So substitute here DL equal to how much? 2 into T into theta equal to mu into DL value how much? R into 2 theta into how much? V square by R. RR theta theta cancels out. So 2 also cancels out. So T is equal to how much? Mu into V square. So V square equal to how much? Tension by mu. So what is the velocity of the transverse wave? Under root of tension generated in the string divided by linear mass density. It is the most important equation. This is called velocity of transverse wave. Velocity of which equation?
V is equal to minus A omega cos kx minus.
That is velocity of the medium particle, which is at horizontal position x meter after t second. That is only velocity of the particle. Only that is velocity of the medium particle.
Yes, sir.
Clear, everyone? The velocity of transverse waves in string.
This is only for string, sir.
Only for string. Everyone, is it clear?
Yes, sir. Clear, sir.
E by mu, sir.
Huh?
Mu.
Under root of t by mu.
Mu value not in substitute, sir.
Mu value is called linear mass density. Okay, one situation we'll see, one important application I will explain on this. Is it clear? What Chiranjeevi, are you any emergency is there? Huh? No. Then when this person will go, you are watching time. Is not punctual. So one application, very important application now I will explain. You people just watch carefully. So for example, students, this is one horizontal ceiling. So one horizontal ceiling, one metal chain suspended like this. What is this? Metal chain. And its length of the metal chain, how much? L equal to 1 meter, and mass of the metal chain equal to, for suppose 10 kilogram. I hold it at the lower end. What I did? I hold it at the lower end. I jerked it. Jerked it means one time my hand half oscillation completed. So halfway will be produced, na? Or one full oscillation completed means one full wave is produced. My question is very simple and straight. What time taken to reach the ceiling? One question is there. This is a JEE question only. Evaluate time taken by the wave to reach topmost position. This is one situation. But can you use direct formula? Time equal to distance traveled by wave by velocity. Can you write direct formula? Time equal to distance by speed of the wave only, na?
Yes, sir.
Yes or no? But distance traveled 1 meter. What is the velocity of the transverse wave formula? Under root of tension by mu. At all points, same tension is there, huh?
No, sir.
No. Here tension is 0. At middle point, what is the tension? This entire weight is producing tension. Correct or not? What a tension at that point? M into G. M value 5 kilogram only, na? So 50 Newton is there.
So M value is
What is tension at this point? M value 10 kilograms. Na. Just below 5 kilograms string only there. Na.
yes, sir. At
That is
midpoint,
only the providing tension.
at midpoint,
At this point Q, what are tension? At the topmost point, total string weight is contributing tension. No?
Yes, sir.
Are you understanding?
Yes, sir.
At point Q, ceiling is pulling upside, weight is pulling downside. Na? Earth is pulling downside. Na? Earth is pulling mean weight only. Na? Weight is how much? 100 Newton. Is it clear, my dear friends, everyone? Why? Because of the string mass, tension is not same. Tension is not constant. So direct formula we should not use. Clear or not clear?
Yes, sir. Should take one small and
Something happened.
it will come again. So why should I remove?
No. It's hanging. See, this cursor is not moving. It's not coming. No?
Coming, sir, but your laptop link. Sir? Problem is your laptop or projector, sir?
I don't know. I just touched the wire, then the online students respond. Hello, say hello.
Yes, sir.
Online students say hello.
Remove the projector. Remove that, sir. Projector problem. Laptop is working, sir.
Hanged suddenly.
Now,
Cursor is
not taking input, sir. Sir, I'll switch off, sir.
I think Chiranjeevi, this SAR is not going. It's hanged.
Laptop has, sir.
Yeah. Cursor is not moving.
Yeah, why, sir?